Who is a system administrator from the Research Computing Service Division at the University of Cambridge in UK, and is working mostly on the group storage services. He's going to talk about IO500, which has become in a couple of years a reference in terms of benchmark. So it's up to you. Thank you.
Thank you. So hello, I'm Raso-Barnett. I'm by day just a Lustre storage administrator at the University of Cambridge. And I was going to do a talk basically about our experience with the IO500 and Lustre specifically this year. So this talk is kind of about a bit about our experience for a few months around sort of late spring this year, where we really focused a fair bit of effort actually in working on a IO500 submission for the June ISE 19 list, in which we managed to obtain a #1 position on the full unlimited client list. And for this we were using our sort of all-flash Lustre-based burst buffer, which I'm going to talk about as well in a moment. But this was quite interesting for me particularly, because this was our second submission on this list, and we used the exact same hardware as we did before, but we had a really significant improvement in the overall score. And this improvement was all entirely from software changes, from configuration, from new features in Lustre that we weren't really using before. And it was really kind of running the gamut of kind of the very latest that Lustre has to offer. So it kind of offered a really interesting view of what's possible. So we're using LNet multi-rail, D&E, stripe directories, data on metadata, and the very latest OST overstriping. And we had a lot of great support and effort with WAMCloud, who were really helping us sort of turbocharge our effort and provide some great tuning advice. So this was kind of the before and after of our score. So this kind of score, the IO500 is a fairly new benchmark suite, but it's trying to kind of provide an overall measurement combining bandwidth and metadata benchmarks with sort of a best and worst case scenarios to try and provide an overall kind of meant to be fair sort of benchmark that represents an overall performance of the system. So you can kind of see in our score we had a fairly good improvement on both aspects. So the columns on the far right show the overall score and then the bandwidth and the metadata scores. So you can see our bandwidth kind of increased a decent amount, kind of got about a 2 times improvement there. But the metadata improvement was, I think, the real major contributor to our improvement. And there's some really specific reasons for both of those, which I'll kind of break down and go into in a little while. But first of all, just about the IO500 a bit more itself. So Andreas Dilger gave a talk at LUG this year, going over the IO500 in a bit more detail. So I'd recommend have a look at that if you're interested. But essentially, it's made up of kind of 5 main benchmark scenarios. There's using IOR for its bandwidth portion of the test, and there you've got an easy and a hard scenario. So the easy is meant to be your typical. You're allowed to tune the IOR parameters how you would like, and to really optimize for the best possible bandwidth that you can achieve. Whereas the IOR hard is a more constrained test. You have limited options. There's most of the options are fixed for you in advance, and it's forcing it to use small unaligned I/O to a single shared file. So actually, in the previous talk, Siuchi was showing he had his single shared file. He had the IOR commands, and these actually match these phases. So the IOR easy is the file per process, and the single shared file Siuchi was showing is the same as the IOR hard. And then you've got the metadata benchmarks. So there's a MD test easy and hard again. And similarly, MD test easy you can tune how you like. So typically that's best as a separate directory per process. Whereas the MD test hard, it forces you to write all processes to a single shared directory, and there's limited tunables for this. And finally, there's a find phase, which is a namespace search over all of the files that are created by the other tests. And it looks for a specific subset of the files that are created by the MD test hard in this case. But that's a search over all files. And this is kind of what you get used to looking at when you're running these tests. You have these test phases. So there's 12 phases overall, 4 bandwidth phases and 8 metadata phases. And each phase has its own results, which are then combined together with like a geometric mean of the bandwidth score, and that's what you see in the table for the bandwidth, and then a geometric mean of all the metadata scores to give that, and then the geometric mean of both gives the total score. And all the write phases have to be 300 seconds minimum for it to be a valid submission. So this is how you get started with the IO500. There's a Git repo, so you can just clone that. They have a compilation script, so they will compile a specific version of IOR and MD test for use using a specific release. So all you need is your cluster's MPI library, get that script, you run it, and it will build the files for you. And then the main thing that you're going to work with is this IO500.sh script. So within that is where you're permitted to make a few modifications. That's actually kind of it's a very user-friendly script. I'll show you in a minute. It just contains a few simple functions, setting up the tests and providing some parameters to set. And then there is another script inside the utilities, which is where the actual tests are run. So it's fairly user-friendly. You can just have a read through that script. And that's what you're going to submit in your batch job. So this is an example of some of the functions inside the script. One of the main ones that you're allowed to modify and work with is this setup directories script. So this is where you're allowed to, by the rules, you're allowed to set up the directories for the tests at the top level. So you can kind of see, I would recommend you would split out each of the tests. So it's going to make a directory IOR easy, hard, MD test easy, hard, because you're going to want to set striping and other turning on separate features for each of these tests individually. And then there's also a function for kind of setting up your paths for, and particularly like MPI arguments and things like that. And then there's also some functions for setting the parameters on the individual tests themselves. So I've put an example here, and this is from the script that I used in June, but I've noted that it's out of date partially because the current IO500, if you clone it today, they've removed some of the need for setting specific numbers, such as here, you kind of setting the IOR easy size. So that's the size of the file per process that you're going to be creating, or the number of writes per process. So the very latest script has removed the need to do that. They've set themselves very large values, and they're relying on the stonewalling within the script, within these IOR and MD test to sort of exit the process after this amount of time specified, like of 300 seconds. So that's made it a bit easier, but this was before one of the places where you would spend a lot of time iterating on trying to find values for these, because these will often determine how big the files are, or how many files you're going to create in the metadata benchmarks. So you would often be, before this change, you would often need to be tuning these quite carefully to ensure that you, one, made enough files to last longer than 300 seconds, but also not to go too far over. And the one thing that has changed here are the actual, the one thing that hasn't changed are the actual tuning parameters themselves. So you're still permitted to set these, which is passed to the MD test and IOR commands themselves. So that's still the same as before. And these are some examples of what was used in June. So there's some general tips that I picked up along the way that are fairly straightforward, but they really make life a lot easier. So just getting organized when you're getting going with this is just a really important thing. We didn't do this before, but it was quite clear after just playing around with this that there's a huge number of tunables. There's a lot to keep track of, particularly if you're changing stuff on the file system. So just taking a little bit of time to come up with your own system to keep track of your iterations, what you're changing, and what the results are will really help you along the way. Repeating configurations is really quite important, actually. There can be a surprising amount of variation in scores between identical runs. So you want to keep repeating them and checking logs and looking at your monitoring to kind of try and understand a bit about what's going on there, because you can have some runs that the performance is much lower, and you can look into why perhaps there was a problem that you hit at that moment. And then time, it does actually take a bit of time to get up to speed with this, and also each benchmark itself takes about an hour to run the full script. So I found that it was quite useful. There's variables in IO500 to just focus on a particular benchmark individually. So I used this to get familiar with what that test was doing just by itself without having to wait for everything else to complete. And that really helped just to iterate quickly and find kind of good parameters for each test on their own. So I'm going to talk a bit about the hardware platform that we used. We have the slightly cheesy name Data Accelerator for the overall thing, but this is what we have is a modest size of all-flash NVMe file system or hardware that we are trying to use in the best way that we can for our users. So we're using Dell R740 XD servers, which each of these have 12 NVMe drives, and we have 2 Intel OmniPath HFI cards per server. And so these are really designed for high performance. You'll notice that we don't have any RAID card or RAID in this system. And the reason for that is that we kind of made a conscious choice with this that we're looking to use this in an ephemeral way. So you'll see that each of the drives we're kind of using individually as OST, MDT, and this hardware platform fits into a wider system for us that is provisioning these as burst buffer-like Lustre file systems that are just used for a job and then are thrown away. So this is we have a software project called the Data Accelerator as well that this fits into, and it's built off of we've taken we're using the Craze burst buffer data warp interface that is like a Slurm plugin for burst buffers within Slurm, and we've made an implementation that uses that interface but creates Lustre file systems on this hardware for us. So There is actually, it's an open source software project. I've got a link here on this slide, which anyone is welcome to check out and contribute and feedback to. But the way it works is users would, in their Slurm job script, would issue the commands, the directives to create a buffer file system of a particular capacity, and Slurm would then run a tool that we've written that interfaces with the etc.d key value store, and that is sort of our database of these file systems, and it produces, it issues the request, and this is then picked up by a daemon on these servers which know about the hardware that they've got and what is being used already and what is free. And this daemon writes out a little Ansible inventory of what it needs to create. So this NVMe, that NVMe, and then it will run the Ansible to go and build that file system for the job, and then it will go and mount that on the client used in the job. And then that is then passed on, and then the Slurm job will start, and the users can use that. So this is where we've been, we envisage using this, and we've been working on this with our users. This is, again, the repo. We've got installation instructions and some quick start demos for people who want to try it out. So there's a Docker demo, which is useful just to try the Slurm portion of this. It doesn't run the Ansible. And there's a larger OpenStack demo, which is much more like a full environment, like what we're running. So, coming back to the IO500, this kind of file system on demand is really like a perfect tool for benchmarking. I think we sort of realized that we were in quite a lucky position to be able to to use this, because we can create and destroy file systems with each job, and that gives us a lot of agility for testing and trying new things. We don't have to worry about the persistency of the data within each file system, because it's going to be erased at the end of the job. And as I said before, this system, we don't use RAID on top of the NVMe devices. If a device is lost, the model is just, okay, that device is taken out of the pool, and the user will have to kind of restart that job, stage the data back in. But given the lifetime of a job in our cluster of 36 hours, that's taken, that's sort of, we've taken that as we're sort of optimizing for the performance over having long-term resiliency of that file system. So all of this really helped us I think we sort of realized that this was kind of a ideal test bed for this kind of benchmarking competition, because it really helps us to iterate fast and achieve kind of peak performance of the system. And so this was the particular file system layout that I was using for IO500. So we have 24 of these servers, and we're using one MDT per server. So we had 24 MDTs overall, and then 12 OSTs per server, so 288 OSTs. And the MDT and OST actually shared a device, so we partitioned that. The MDT was about 100 gigabytes in size, and that overall led to about 450 terabytes of overall size in the file system, and about 1 billion inodes, which was important. I had to keep increasing the size of that MDT because with the kind of number of files created, it was actually filling a significant, about 600 million files in a single run. So that needed to be big enough to accommodate this. So this is kind of what the process looked like in the benchmarking process. So what I was doing was I actually worked off of the Data Accelerator code base, but I was customizing it a little bit. So I was adding new features that we haven't yet merged back into the upstream code base. So the main one was I was adding the server and the client tunings to our Ansible code. So you can kind of see on the right, there's a sort of what the burst buffer inventory file looks like when it's produced by those DAC daemons. So it kind of shows the particular block devices used and their OST or MDT index number. And then I've been adding sort of Ansible plays to do some of the file system tuning as well, which is sort of these variables down at the bottom. So most of the tuning stuff hasn't made it back up yet, but this is something that I want to unify in the coming weeks, so that the hope is that this can be something that I can just run out the box with no modifications used on our cluster. But the nice thing about this is that having the Ansible inventory, it really produces like reproducible configurations. So it helps again with that organization side of the benchmarking, because then we could have a particular version of the software, a particular Ansible inventory, and then the results of the benchmark as like a reproducible configuration that we should be able to then rerun in a few months and see. So all of this kind of began around April 2009 when we started playing around with this. And for me, at least, this was my first experience with IO500. So it took quite a bit of trial and error just getting used to it. I think I'd really advise like starting out small scale with a few clients, just doing the individual tests, getting used to what they're doing, understanding a bit about how the script works. There's a large parameter space to explore, as I said, so it really helps to just get that familiarity and iterate fast first before scaling up. And there are a number of problems along the way. Like cleaning up failed runs was unexpected, but when you're creating millions and millions of files and then the job fails in some way, having to remove those ordinarily will take a long time. That's something where just being able to blow away the file system really helps. But there was also some issues with the pfind, a lot of things where it just helps engaging a bit with the IO500 community. So there is a mailing list, and they have a Slack channel, which is really useful. So I spent a lot of time just reading and talking to people on there just to when encountering some of these issues. Another thing was using the same nodes and understanding your client nodes. So originally, I was just submitting jobs into our cluster, and I would get different compute nodes in each run, which is fine. That's what our users would do. But when we really started going up to larger numbers of clients, like 512 and so, I started hitting issues that we started suspecting, where we had kind of slightly non-healthy nodes in the cluster that we weren't aware of. And I had some help with colleagues who started running other benchmarks like HPL and things on the nodes at larger scales, and that really helped actually flush out some subpar nodes that we weren't aware of. So this was kind of our initial, or like the result of my kind of initial testing with IO500. So after a few weeks of getting familiar and scaling things up and trying to apply various best practice tunings, we had a fairly sizable improvement pretty much across the board in our score. So in nearly all cases, other than a couple, we had large improvements. And we were really hoping for this, because we knew when we made our first submission in November that we had kind of rushed that together, and we had made a few mistakes, and we hadn't really spent any time really tuning the hardware very much. So this was really nice to see. We had, I think the main thing that is really draw attention to is actually the MD test easy write performance. That had a massive improvement, and that was very directly attributable to using DNE, which we weren't doing properly before. So there were lots of improvements, some general ones, like I said, a bit more time dedicated to benchmarking just helped avoid some bad mistakes, and the known good nodes, as I mentioned before. Using Lustre 212 on the servers was a major improvement. There's actually a really good talk from LUG 2019 that Suchi did about Lustre optimizations for Flash. And that was a big thing for us. So there was some improvements, I think, particularly around the use of the page cache that it optimizes for, and that was in itself a major part of this. And then, as I said, we had 24 MDTs in this file system. So using D&E properly this time was a massive contributor to that change. So in this particular case, I was using D&E1 remote directories for MDT Easy. So that was where every process had its own directory, which wasn't striped, so that was just pinned to a particular MDT. And then for MD test hard, I was using the D&E2 striped directories. I will say that I wasn't using D&E1 for the MD test easy was largely due to me. I was hitting an issue at the time, only occasionally, where I'd hit some problems and kind of see errors on the server causing problems with the file system and having to abort the run. So I was trying to use actually striped directories for both, but these kind of stability issues led me to not using it for MD test easy. But I think that's something that when with some more testing in the future and coming around to, we can get to the bottom of. It was quite a rare occurrence, but it was enough just to make me avoid it for the time being. Other obvious things were just using more client processes per node. So that has a big impact. More client processes is, with enough bandwidth and IOPS on the back end is enough to improve things by itself. And then we're using POSIX iDirect on IOR Easy and MPIIO on IOR Hard. So those had an improvement on the bandwidth scores. And we were getting much closer to our peak bandwidth with this. So we're limited by the OmniPath dual rail or multi-rail on the server end, setting pretty much like close to 600 gigabytes a second limit on the servers. So we were kind of getting into the territory of sort of 530, 540 gigabytes a second on the read speed. And our IOR Easy write speed is limited by the NVMEs themselves. So we were, again, getting quite close to the limit there is around sort of 380, I think, 400 gigabytes a second on write, like theoretically possible. So we were quite happy we were getting the bandwidth up. So then we had the next kind of real phase of leading up to our final submission. And with this, we had we had some we engaged with WAMCloud during LUG at 2019, and we talked a bit about what we're doing, and that continued after LUG, and we talked to them a lot, and they gave us a lot of advice and some sort of ideas on things we could try, and this is what really led to the next major jump in our score. And I've kind of highlighted, this really shows very specifically on these particular tests. So our IOR hard write and our MD test stat and delete scores were the big drivers in that improvement. So why was that? So with this engagement, WAMCloud shared that there were a number of improvements going on at the time on master. So one of the big ones was the aforementioned OST overstriping that Suhushi mentioned. So this was available on master. So by upgrading all the servers and the clients to master, we could make use of that. And you can see here the improvement on the IOR hard write score was really quite dramatic. We got almost a 4 times improvement in that alone, just from enabling that feature. And then the second major part of that was on the metadata side. So,
excuse me, how many slides?
Am I over? Sorry, it's only a couple more slides actually. Sorry. Yeah, so by upgrading to 212 on the clients, we were able to make use of the data and metadata. And again, there were some specific improvements that were landing at the time that WAMCloud shared with us that we could make use of. And that really drove these massive improvements in the MD test stat performance, particularly. That MD test easy stat score particularly was quite dramatic and suspiciously large. I didn't quite believe that at first, but it was essentially measuring like a cache effect. So this is what Sahichi mentioned in his talk. MD test at the time was not operating in a strided mode, meaning that the stats and lookups were able to happen from the same client that created the file. So effectively, what the data or metadata feature, the patches and tunings that WAMCloud shared with us, it really enabled, I think that was really targeted at not invalidating the locks on these files after they were created, which really allowed basically the MD test stat to make advantage of these files all being in the local cache on the node. And that led to this dramatic improvement. But this has been noted and fixed in the current IO500 script. So I should say, I don't think we were the only site making use of this. I've seen others in the full list that were also having similarly very high scores on the stat, like in a similar range to us. So I think everyone will be on the same playing field when this test is changed in the future. So, okay, there was the list, the full list, and we had a 10-node challenge score as well. But I'm going to skip on and just say, like, just wrapping up, like, it was a lot of effort that we put in just for a benchmark, but there was a lot, I think, that we gained a useful experience as a team around this. In my day job, I work with like our Lustre. We have a normal traditional Scratch. We have the tape system, NFS filers. So there's not often we're so focused around performance outside of a few benchmarks on a new system provisioning. So this is quite a different experience for me. It was quite disruptive at the time, particularly towards the end. We upgraded a large portion of the cluster to 212.2 clients, which is not our production configuration. So that was quite disruptive for kind of a crazy weekend of mad benchmarking. But I think it was valuable. You know, we gained a new insight into some of the latest features coming out, a lot of these performance improvements that are landing, and a lot of things that I think we're going to take back and feed into our future traditional kind of Scratch disk-based tier, and particularly around the metadata. This was my first experience using D&E, data on metadata at any kind of scale. So this is something I think I'm really going to take seriously in our future designs, our next metadata design. So just lastly, our focus now is really back on this, the DAX software itself. We have some users at Cambridge who are using this, and we're really going to try and feed back a lot of the improvements that I mentioned back into the software. And it's open source. We're trying to, most of the day-to-day usage of it that we're using on our cluster is the upstream code. So we're trying to work upstream with it. And if other people use it and have improvements that they would like to see, then let us know. And just very, very quickly, last thing, we're also quite interested in probing more about D&E at very large scales. So right at the time, we used 24 MDTs in a file system, but you know, we have this possibility of being quite flexible with this, with our file system on demand. So I've started exploring kind of going much larger than that, and have some ideas, already some numbers on 48 MDTs and maybe going larger, just for fun. Okay, and thank you for all of the engineers at WAMCloud who really massively helped with this effort, and all my colleagues at Cambridge as well for the help. So thank you.
Thank you, Mike. It's very interesting.
Should I get, am I out of time? Yeah.
Any questions?
Is there any questions?
One question. Do you have a Jira ticket for the hang related to striped dirs?
Could you say that again? Sorry, I didn't hear the last bit. A Jira ticket to?
A Jira ticket for the hang. You mentioned your attempt to use striped dir resulted in hang, file system hang. So I would like to see a Jira ticket for that.
I do have one, but it was quite a rare failure. So it's open, but I think it's something that's going to need to wait until I'm doing some of this work again at scale, because it's really, I only saw it at the very largest runs, so 500 clients, 24 MDTs, striped in the MD test easy. So at the very, very largest, and there it did lead to some problems. So there, I can share. I don't have a slide with it, but I can share the LU number. But I think I need to get some more testing and data to be able to.
Actually, do you observe the same hangs at a smaller scale?
The same problem, you mean?
Yes.
No, I haven't seen it at smaller scale. So it must be something to do with the amount of creations that are happening, perhaps, and something not keeping up. I'm not sure, but yeah, it's only at the very largest scale I saw that.
Okay, thank you.
So no problems with 24 or 48 MDTs?
Yeah, other than this mentioned occasional issue, no, it actually works really well, like impressively well. And I must admit, the only reason I didn't go with 48 was just kind of almost exhaustion with the number of configurations possible. I kind of, 24 was quite a natural due to the way our hardware was arranged early on. So I kind of arrived at that, and this testing was actually done post the submission. It's not using the same Lustre and versions that I was using in the actual submission. So the performance here, you can see some of if you compared it with the tables that I showed before, they're a bit lower, but it was all kind of done consistently with the same version, kind of showing the increase. So I think in future, I would definitely try with 48. There is a problem with going beyond, I think, 64 at the moment, and there is an LU I've opened about that. I think it's been noted by other people before. So that currently prevents going beyond, well, for me, 48, I'm kind of increasing in 24 increments to kind of make our Ansible a bit easier. So I haven't really gone beyond 48, but there's some, I think there's a kind of a rough non-production-y workaround that I might try to go beyond that just for some kind of interesting testing, like how does this go up to, potentially 288 MDTs, like have one per device in our system, just to see, how does that look like with scaling.
So thank you again, Matthew.
Thanks.